Second part of section 4.3, example 12. As well, have to evaluate log there's two ways to find the solution. You have two types of logs. You have log with base and you have log without base. You can use the one without base. You don't have to write down the base 10. So how much if you plug in log to the base 0.0001? So maybe -1. Let's spend -1.
I think I put her in wrong. I got -4.
You get -4 because how many? 1, 2, 3, 4. That's why it should be -4. 13. That's important. 13 and 14. Based on that, we're gonna learn some rules. Have ln e to the -3. That's why I'm saying there is another rules. We have to learn that about how to evaluate this part. Let's go to the properties. The properties, it says every time when you see log to any base form 1, how much the result? 0. Okay. If we see log base with the number, it's exactly the same for the x. How much the result? The value of x. That's mean if you have 5 here, it's going to be 5. If you have 1,000,000 here, it's going to be 1,000,000. Okay, but the condition it should be the base equal to the number. Is that okay? So the result is going to be the exponent. What about if we have log base with the same base? How much the result? 1. What about if we? This is really important, and you will see we're gonna use this one the whole time. If we have log to the base b for the x equal log to the base b for the y, that means x equal. This is really important, okay? And you will see we're gonna do the same thing with the ln, which is the natural log. Let's go back to example 13. Who's gonna tell me the natural log? Is there another form to perform the natural log? Log to the base e. So if I write down the natural log as a log to the base e to the -3. Now can I use one of these properties?
Third one.
The third one, there's no exponents here. Can I do the second one? The base similar to the number here. So what's the result? The result is -3. Again, we're gonna learn more properties how to evaluate. But I'm trying when I explain you can plug in everything in the calculator, that's fine. But when I'm trying to explain, every time when you see ln with the e, you don't have to do these steps. You see, we did the steps. How much the result? -3. So every time when I see ln to the e, that's it's going to be log to the base e. And based on log to the base e, I can use this property, and the result is going to be what? -3. So in the future, every time when I see ln with the e exponential function, I'm just going to cross these out. What's the left? What's the left?
-3.
That's it. This is the result. We use this one in the future, so keep in your mind every time when I see ln with the base e, the result is going to be -3. And for this one. For now, you're just going to use the calculator. This is example 13 on section 4.3. Okay, you already have it. Oh, I'm using it. I'm using it.
Oh yeah.
Who I gave you 2. I give it to him. Okay. So I'm using. I don't have it. Use that one. can write down numbers. Can we do the same thing with number 14? So with number 14, if we have ln e to the 10, do I have to do the same steps? Yes, you can do the same steps. You can say the ln is log to the base e. Okay, you can say that ln is the log to the base e to the power 10. Or you can say, okay, I can cancel this, what's the left? So both ways going to be right. But we have to learn in the future, every time when you see ln to the e, we're gonna do these steps, which is gonna cross out, the left is what? -10. So this is going to be the result. Is that okay? Number 15. Believe me, there is a bunch of numbers. I don't know which one is that question. They ask you to find log 200. Go ahead. You know how to use the calculator? Log to the 200. Because I'm telling you, we're going to use another way. But for now, I don't want to make it hard. $15, $16, $17, $18. Work on these. Okay. Let's check. I add another rule. Every time when you have a number and the number with exponent, this is the whole thing is exponent. Log to the base of x. The result is going to be what? X. Now tell me, plug in log to the 200. How much is the result? And let's choose 4 decimal places. Is that what they mentioned? 4 decimal places, right? Ask to round to 4 decimal places. So how much you got for the 200? 2.01. 71?
01.
2.01. Okay. What about log 0.074?
1.1308.
13 all the way?
08.
08? No.
08.
08. Okay. What about ln to the 200?
29.
5.29?
83.
83. Now I'm going to ask you a question. What's the difference between log 200 and log ln 200? Why we got 2 different results? The base is different. The base here is 10. The base here is what? E. Log to the base e. That's the difference. That's why we got 2.
That's a bit different from 16.
416. How much you got?
-2.6036.
Let me check. What number is that? 16? It's the same number, but it's negative. You got negative?
Yeah, negative, yeah.
Maybe you forgot the negative sign.
Oh, yeah.
It's negative. The same number was negative. Okay. So you know the difference between ln and log? Because we have different bases. Okay? So this is base 10. This is base log to the base e. Now what about ln 1.005? How much is going to be?
0, 0.
005.
How much?
005.
005. And this?
Yeah.
Okay. Now we're gonna use. You can use the calculator now with this one. But now look, do we have a property similar to this one?
Yes.
When the number is similar to the base, how much is the result? That's it. So the properties make everything easier if you memorize the properties. I'm telling you that we're gonna learn a lot of rules. So you write down the rules in one page, but if you not practice how to use the rules, you don't know how to use it because we're gonna use more than one rules on the same time. What about log 10? It's going to be 1. Why?
Because invisible 10.
Because the base is 10. So log base, the same number 10, so the result is going to be 1. What about ln to the e? It's going to be 1. Remember I told you every time when you see the ln with the e function, just cross it out. So the result is 1. Why? Because the ln, it's log to the base e, and here is e. So it's similar to which one?
13.
That's this one. So the result is going to be 1. That's why every time when I see ln with the e, I'm going to put 1. Log to the 1 for any base equal 0. The first one, log to the 1 to any base equal 0. Okay. You can see the rest. Okay. What about log 1 to the base 1/8?
0.
Still 0. Log 30 to the base 30. 10. Which property is similar to this one?
2.
Number 2. So what's the result?
1.
Ln to the base e negative 12. It's going to be cancel these negative 12. Is that okay? Go to the next one. What about if we have 10 to the exponent log to the base 10, 14? How much is the result?
14.
14 is the last new properties I added. When you have a number and the whole number is for the exponent log and the base for the log is similar to the number. So the result is going to be 14. The same thing here. 8 log to the base 8 for the 5. What's the result? 5. That's it. So we're just using how to evaluate. And again, when we solve the equations with logarithm, going to be a part of this how to evaluate. So it's fine if you're using the calculator. I'm not gonna say that, but we're gonna learn another way to find it without the calculator. To cover the whole properties. Okay. Now, which number are you gonna choose? And the difference here, remember what we did on the previous one? We have to choose the value of x, and we're gonna get the y. But the function is the graph y equal log to the base 3 to the x. How are we gonna do that? Choose any value of x. Which x are you gonna choose?
3, 6, 9, 12.
You choose a 3, 6, 9, 12. 3, 6, 9, 12. I think that's enough. Let's choose another number. Choose negative.
Graph don't show negative, but we could, right?
No, but why we can't choose negative? That's a good point. I'm gonna choose one negative number here and tell me what's gonna happen. Choose negative 5. Okay. Okay, now go ahead. Let's try, because like on the test, when they ask me to graph it, I'm gonna choose positive and negative number and try what's gonna happen if I choose negative number.
Domain error.
What's that mean? They're telling you domain error. What's that mean?
It's past the asymptote, or I don't know.
No, it's domain, which is okay. But it says domain error. That means our domain with this equation start from which point? From 0. Go ahead and start putting the 0 here.
It's the same thing.
It's the same thing. So if you put 1, you're gonna get a result, right? If you put 1, how much is going to be?
0.
0. If you put 1, it's going to be 0. That's mean for the log, domain start from which point? From 0 to infinity. That's what I can choose. And the range is from, first of all, when you put the 0, you get an error, right? So is that right? What do I have to do here?
Parentheses.
Parentheses, that means I can't include the 0. Now the range starts the first number, which is 1. When I plug in 1, I'm gonna get a result which is
0.
so this is the range. Is that okay? So that's mean don't pick negative number. Yes, and you're right when you said even what it shows here, there's no negative numbers. It's started from 0. That's also a smart way to think. But what about if there's no the chart here? Plug in, start, okay, plug in negative number and positive number and check where is going to be the domain error. With the log, with the len, always positive. You can't accept the negative number, okay? So how much you get for the 3? When you plug in here, because our function y equal log to the base of 3. For the 3, you're gonna get 1. What about 6?
1.63.
How much?
1.63.
63. What about 9? Be 2?
We try 9 here.
Oh, that's been muted error.
Oh.
2 is going to be 2. What about 12? 2 something.
2.6.
2.26. Now can we graph this? Choose another number. Choose 20. Let's choose 27. I did that on purpose.
27 is 3.
27 is a 3. So here on the graph, when it's a 3, it's going to be 1 here. When it's 6, it's going to be 1.63. Kind of here. Keep going. When it's 9, it's going to be 2. When it's a 12, it's going to be
261.
which is kind of here, right? When it's a 3, not 3, 27, going to be 3. Tell me, how is to calculate the function? We jumped. You can choose a number here, but kind of, can you tell the function of the black what? Is that my email? You can tell the function of black what? Goes down like this. I'm gonna go back to you. You said we can't choose negative number because it's going to pass what?
Asymptote.
The asymptote. So where is the asymptote? The asymptote here when it's 0. Because the function never going to cross the asymptote because there's an asymptote here. Because we can choose negative number and the result is going to be error on the domain. So when I choose 0, plug in 0 here is going to be error. That means this one is an asymptote, the first one. I can't cross it, okay? You got the idea how to graph it? Now can we do the same thing with the next one?
For the X, do you just randomly choose numbers or does it have to?
Just, because we choose this is as a domain, right? So randomly choose any number.
Okay.
But always I'm start from number closer to the 0. So I can look where is the function start. Like I'm not gonna choose 100 and I'm gonna see here. I need to check the closest number to the 0. Choose 1, choose 2, choose a 3, it doesn't matter. That's why it's clear, the graph.
Yes.
So we said we're gonna choose 0, 1, 2, 0, 1, 2, 3, and I said -1 and -1/2. You choose these numbers. And as you said, they give you the negative side. And I say, why they're gonna give me the negative side here on the graph? So I'm gonna choose -1 and -1/2 to see what's gonna happen on the graph, okay? So if you look to the function, y equal log to the base 2, 1 plus x plus 2, okay? You're gonna learn two things if they ask you. First of all, tell me when you plug in 0, how much you're gonna get? Tell me the result. How much? Just 2? Was this it? Okay. When you plug in 1, when you plug in 2, how much?
5.
8, okay. What about 3? What about -1? Domain error, okay. What about -half?
1.
Okay. Half, which is less than 1, okay? Now, can we graph it? We're gonna learn two things, I'm telling you. The first thing, why I can't choose negative number here? We said before, the domain from 0 to infinity. We can't choose the 0. But why I could here, with this example, I could choose this number. It's a negative number. Because as Carlos said, you see, it's a +2. Remember?
The plus 2 or
It's in the inside. Minus.
Oh, here.
plus, right?
Because the +2 is going to be shifted up. Remember when there is a number outside the function, it's going to be shifted up? But when there is a number inside, x plus 1 is the same thing, 1 plus x. This one is the same, like x plus 1. So it's going to be shifted to the left. How many units? 1 unit, because it's a plus. If it's minus, it's going to be shifted to the right. So that's why this reason we can't choose the -half. But why we couldn't choose -1? Because it's an asymptote. So here's another way. When they ask you find the vertical asymptote, you're going to take everything. It's a log to the base 2, 1 plus x plus 2. When they ask you to find the asymptote, I'm going to take everything inside. This is only with the log. 1 plus x equals 0. How much is the value of x? So this is the asymptote. Now take everything belong to the log, solve it. 100% is going to be, this is the asymptote. If you go back to the previous example, take everything inside for the log and equal to 0. How much the asymptote? For the previous example. For the previous example, we have what?
0. I mean, it was 1.
Log to the x to the base 3, right? So I'm going to take everything belong to the log and equal to the 0. So this is an asymptote. That's why I couldn't choose the x equals 0. It's an asymptote. So the first thing when I'm trying to graph, I'm going to look where is the asymptote. So after the asymptote, I can choose any number. So the first thing, before I start graphing, I'm going to look to the asymptote. I'm going to look, take everything x, 1 plus x equals 0. So x equal -1, this is the asymptote. That means I can choose -1. I can choose -half. I can choose -0.25. I can choose 0. I can choose 1, 2, 3, and keep going. You get the idea? When you're graphing, what's the first thing? Locate where is the asymptote. Because I can't choose the asymptote. I can choose any number after the asymptote. Is that okay? Kind of, it's easier to check where's the domain. And you can grab the rest. With 0, it's going to be 2. With 1, it's going to be 3. With 2, it's going to be 3.58, kind of here. With 2 here. With the 3 is going to be 4. With half, it's going to be 1. So with half here is going to be 1. And here is the asymptote. So the graph never going to cross the asymptote. It's going to be like this. Is that okay? Easier now? That's what we're going to learn on the next example. First thing, I'm going to locate the asymptote. And then when you graph, you can choose everything after the asymptote. With the example theory, what they're telling you.
The domain and the range.
and the range. Okay. Okay. Based on this, okay, I'm not going to look to the graph. I need to find the domain without looking to the graph. What I'm going to do? What I'm going to find? The asymptote. How am I going to find the asymptote? Take everything belong to the log, which is x plus 3 equal 0. That's mean x equal -3. That's mean my domain starts from which point? -3 to infinity. So this is the domain. Domain is going to be -3 to infinity. Is that okay? Can I choose -3? No, it's going to be the number after -3. You can choose -2.99. You see, it's really close to negative. It's going to work, but I can't choose -3. Now, what about the range? Without the graph. Don't look to the graph. Like if you need to find the range without the graph, because with the graph it's going to be easy. What are you going to do?
Negative infinity to.
But how? So my domain, I know started from -3. Now, to find the range, say it.
Plug it back in.
Perfect. You're gonna plug in the numbers to find how much is going to be the y value. So if I pick a number really close to -3, which is -2.99, go ahead and plug in this number here. How much is going to be? Don't forget the base is 2.
.64.
-6. So this is, you took which number? You took -2.99. What about if you took -2.9999 and keep going? So the result also is going to be where? Going where? Going down. You get the idea? So every time, because if you choose -2.99, it's really close to -3. But if I choose -2.999, this number is closer to 3 than -2.99. You get the idea? That's why the range going where? Start from negative infinity to where? To positive infinity. With the graph, it's easier. They're trying to make it easier, but I need you to think how I'm gonna find the range without looking to the graph. You get the idea, or you're still lost?
I'm here.
Okay. So the range is going to be negative infinity to positive infinity, and kind of always the range is the same. If you look to graph 1 and graph 2, always going down. But we need the main thing here, we need to locate the domain, start from which point. What about this one? You can tell the domain is
0. Oh wait.
the domain 0 to infinity, because we're gonna take the domain, sorry, x equal to 0, which is this is the vertical asymptote. Okay. Now, why the graph is different than this graph, different than
Because it's negative. The negative.
what's the negative sign doing to the graph? It'll be reflect over x-axis. So the graph, instead of should be here like this, it's gonna reflect like this. You get the idea? So the whole graph is reflect. Was this negative sign? But the main thing here, we need to find the domain. The domain started from
0
infinity. What about the range? And you can tell from the graph, this one goes to negative infinity, positive infinity. And the vertical asymptote is 0. Is that okay? I think that's it. Don't worry about the last one. So we're gonna do the same thing. How are we gonna find the domain for this one? As we said, we have to take everything belong to the log and equal it to 0. For some reason, I have different one. So we're gonna take x squared minus 3x minus 4 and equal to 0. How are we gonna solve it? By factoring. X and x, I put 4 and 1. When I'm gonna put the sign here? Plus. So how many asymptotes do we have? We have 2 asymptotes. That's why we have 2 plus for the graph. So x minus 4 equals 0. That means x equals 4. And x plus 1 equals 0. That means x equals -1. So check here. We have -1 as an asymptote, and we have 4 as an asymptote. It goes by 2's here. Now, how are we going to write down the domain?
Negative infinity
To -1. So from -infinity to -1, I'm going to put parentheses because I can't use -1 as a number because it's an asymptote. If I plug in -1, it's going to be domain error, okay? And union with what? From 4 to infinity. And the range from -infinity to +infinity. That's it. Is that okay?